My name is Dustin Mackey and my lab partner is Ryan Cyrus, and we are students at Oklahoma State University in the Electrical Engineering Department. And we're going to teach you how to convert from AC voltage to dirty DC voltage. On our breadboard we have two LED arrays hooked up. One array of 3 LEDs just connected in series to DC voltage, the other connected to a 555 timer which gives you an AC voltage. And this is going to show you the difference between the AC and DC voltage. And as we plug it into the timer, you can see the lights flicker. And obviously you do not want this flicker, because when you flip your light switch on at home, you want your lights to stay on. You don't want them to flicker. You don't want to have strobe lights in your house. Well, some people might want to have that, but for the most part you want a constant light. And so also this is inefficient, and whenever we connect the voltage to the 3 to show you a DC voltage connected to the LEDs, you'll see that the lights stay on constantly. They don't flicker like they did with the AC voltage. They're just constant on, which is good, which is what we want. Here we're showing the schematic of the AC voltage connected to our LEDs. And here we're using 9 volts as our supply, and we have two columns of 3 LEDs in series with each other, and those two columns are in parallel. And this is what we showed you earlier, the connected to the 555 timer, showing you the AC voltage. And so you see that on the positive half of the sine wave you're only going through the LEDs, while on the negative half of the sine wave you're not going through the LEDs at all. So here this is inefficient. We don't want that. Another way to look at it is you get your same AC voltage supply, and one row of LEDs connect the same way, but however the other row of LEDs, you would invert them. And what this does for you is this gives you half of your LEDs on at one time and half of your LEDs on at the other time. Because as the current flows, it'll go through that row of LEDs, and as your negative part of your sine wave flows, it'll go through that half of the LEDs. This is also inefficient because you only have half of your LEDs on half of the time. We want all of our. Another method you can use is what we call a bridge rectifier. And so you have your sine wave, and when your positive half of your sine wave goes, current flows from negative to positive. So therefore your current is going to flow up, and once it hits this node here, it can only go one direction, because in this direction the diode is facing the opposite direction, so it can only go through the current, or the properly faced diode. And the same whenever you hit that node, so it goes across the resistor, back down, and you have current flowing from negative to positive. And so it'll make this point, the right side of that resistor, negative, the left side positive. And same for the negative side of the sine wave. You go down because current flows from negative to positive. You can't go through that diode, have to go through this one. And again, your current is flowing from negative to positive across this resistor. Here I've redrawn our bridge rectifier, and as you can see I've added a capacitor in there in parallel with that resistor, and that's just to make things a little more steady. And so now I'm connecting wires to the negative and positive end of this bridge rectifier, and these are just going to be our positive and negative nodes for our LED display. And we're using 20 LEDs, which is going to be 4 columns in parallel with each other with 5 LEDs in series, with a current limiting resistor at the end. And so now I'm going to skip ahead a little bit just so you don't have to watch me draw 20 LEDs and 4 resistors. Here we have our finished schematic of our 20 LED array with current limiting resistors at the end of each. And we used 80 ohms for that current limiting resistor, just for current sake, because LEDs don't want to burn our LEDs out. And now I'm going to skip ahead. Here we have our completed circuit. These are the 4 diodes used as our bridge rectifier. and in there you can see a resistor, and then those two orange wires connect the resistor in parallel with the capacitor, and the capacitor again is just there for stability's sake. And then we have these two green wires connects the positive and negative ends of this bridge rectifier into our power rails. That way it's also simple for us to connect our LED display. And so the LEDs just plug into the positive end of the rail, flow across to the negative end, complete the circuit, and that is how you convert from an AC voltage to a dirty DC voltage.